Welcome to topic 3.1.
Okay, in this topic, you will learn about the different kind of controls in the AHU, okay, in the air handling systems, as well as what are some of the energy savings methods that you can use, okay, inside the air handling system. So this is a very typical schematic of a BMS schematic of an AHU, okay. So you can see over here there are a lot of data that is being shown, okay. It includes the various temperature, your mixed air temperature, supply temperature, your water temperature, okay, as well as the humidity, okay, return air humidity, and the static pressure, etc. Okay, so how do we know which one of them will affect, okay, the rest of the parameters? Okay, so over here, right, some of the points we call it input points. Okay, that means points that is picked up by sensors. For example, temperature, humidity, static pressure, they are all input points. And there are some points that is called output points. Okay, what do you mean by output points? For example, your control valve position. Okay, your VSD speed. Okay, your damper position. So all these that's being controlled by an actuator, okay, is called output point. So with that, okay, we will come to this thing called the closed loop system. Okay, so closed loop system, you will always need an input. Okay, you will need an input to generate a suitable output. Okay, and what is actually in between is your controller. So you can imagine controller is like a brain. Okay, like a brain inside the control system. Okay, so in building, usually they will use DDC, direct digital controller, okay, as the brain, where you input your set points and the type of control you want to use. Okay, so sensor, okay, sensor will pick up the input. Okay, so such as temperature sensor will pick up temperature. Okay, and it will compare with certain set point. Let's say it's too hot or too cold, and it will cause a suitable output. Maybe open the damper a bit more, okay, or close the chilled water valve to make sure that after some time you are able to hit your desired set point. Okay, so that's the general idea of what is a closed loop system. So now we will study four kind of control loops. Okay, four main control loops that you can see in a typical AHU. Okay, so first you have your space temperature control, okay, as well as your static pressure control, CO2 control, and your supply air temperature control. So all these, you will always see a suitable sensor, a desired set point, and the output device. So the output device can be a valve or damper, etc. Okay, let's look at temperature control first. Okay, space temperature control, which is the most common type of control. Okay, so for example, inside a room, okay, inside a room, let's say you have there are two type of control that we have. One is called pressure dependent. The other one is called pressure independent. Okay, so pressure dependent control, right? Your damper position, okay, the VAV damper. You imagine this is your damper. Okay, it's a piece of metal. Okay, so when it rotates to the parallel with the duct, right, all the air will pass through it freely. Okay, but if it rotates to a perpendicular position, okay, your air will be blocked. Okay, so the position of the damper will affect the amount of airflow passing through the duct section. Okay, so pressure dependent, your damper position is modulating because of the temperature. But for pressure independent, your damper position will modulate because of airflow reading. Okay, but your airflow reading is actually affected by your temperature. So it's an additional loop, okay, or additional parameter for pressure independent. So what are the sensors that's involved over here? Of course, your room temperature sensor. Some of the sensor is actually hidden in your thermostat. Okay, when you enter the room, sometimes you see a thermostat that you can adjust the readings. Okay, sometimes inside there's a temperature sensor. Okay, and the output device is the actuator that control the damper. Okay, to rotate the damper perpendicular or parallel. And the desired set point for room, as we know, is always around 24 to 26. Okay, so this control loop is very common sense. If the temperature is too high, okay, if the temperature is too high, your damper will open. When your damper open, more cold air will be thrown into the room. Okay, so sooner or later, your temperature will drop until it hits the set point. Okay, so similarly, if your temperature is too cold, okay, your damper will start to close. You will throttle to the closed position, and sooner or later, your temperature in the room will start to increase to the desired set point. Okay, how about pressure independent? Okay, pressure independent is when the temperature is too high, your airflow set point will be adjusted to a higher value. So for example, let's say your temperature now is 27 degrees Celsius. Your initial airflow is, let's say, 1000 cmH. Okay, flow set point. Because this temperature is too high, right? And it will cause the airflow set point to increase to maybe 1200 cmH. And because of this increase in airflow set point, okay, now your damper will have to open, okay, throttle to a more open position, okay, maybe from 70% open to 90% open to allow more airflow into the room. Okay, so there is an additional sensor involved, that is your airflow sensor, that is usually mounted at the outlet of your VAV box. Okay, so the damper that is controlling is called VAV damper, okay, and this whole unit we call it VAV box. So that is space temperature control. Okay, how about supply air or off-coil temperature control? Okay, so if you look at the schematic, okay, if you want to control the temperature over here, the off-coil temperature, that means the temperature that just passed through the cooling coil, okay, the most direct way to control it is by adjusting your chilled water. Okay, the amount of chilled water that is flowing into your cooling coil. Okay, so let me illustrate this. So let's say at the AHU side, okay, you have a fan and you have a cooling coil here. So if I want to adjust the temperature over here, this one is called the off-coil temperature. This is called the supply air temperature. Okay, so before the fan is called off-coil, after the fan is called supply air. So off-coil temperature, let's say, is too high. What it will do is, it will try to open the valve, okay, open the valve at this chilled water valve at the cooling coil to allow more chilled water to flow through. Okay, to allow higher flow rate of chilled water to pass through, such that your air temperature will start to drop. Okay, your air that is passing through, okay, will start to drop in temperature when you allow more water to go into the coil. Okay, so that is the control feedback. Okay, so temperature too high, okay, open the chilled water valve such that more chilled water flow through, and finally your air temperature will start to reduce to your desired set point. Okay, so usually the desired set point is around 13 degrees Celsius, 14 degrees Celsius. Okay, so if let's say it's very high, like 17 or 18 degrees Celsius, then it will start to open the chilled water valve more, okay, to allow more heat transfer. How about static pressure control? Okay, static pressure control is using a static pressure sensor that is mounted around 2/3 down the supply air duct. Okay, so air duct network is very long. Okay, it will be mounted quite far away. Okay, 2/3 down the supply total air duct length. And the output device is actually your VSD. Okay, the variable speed drive that is controlling the speed of the fan. Okay, so if the static pressure, so what happens is, when static pressure is too high, okay, let's say static pressure is too high, okay, what will happen is, it will ask the VSD to ramp down, okay, VSD to ramp down the speed of your fan, okay, because static pressure high means the air duct is very pressurized, okay, that means you have too much air that is going past the air duct. Okay, so it will ask the VSD to ramp down the fan speed. Okay, to make the fan go slower, your static pressure will slowly decrease to your desired set point. Okay, so that's the control behind static pressure control. Okay, so the desired set point usually for static pressure is around 150 Pascal to 250 Pascal. So if you want to adjust this value, you have to do it through the BMS. And finally, CO2 control. What is CO2 control? This one is a strategy, right, to reduce the amount of fresh air into the space. Okay, because as we know, fresh air is only needed if we want to replenish the oxygen content in the air and remove carbon dioxide. This is for good indoor air quality. Okay, so instead of putting in excessive amount of fresh air, which is unnecessary, because it will cause your mixed air temperature to increase, it will cause a higher cooling load. Okay, so they always try to minimize the amount of fresh air going in by installing this thing called a CO2 sensor. So if your CO2 sensor sense that your CO2 level in the room is still within limit, okay, that means it's still at the healthy level, it will ask the fresh air damper to be closed fully. Okay, that means you will have 100% recycled air. Okay, it will be 100% recycled air in the room. So if your CO2 start to pick up, okay, because of occupants occupying the space, when it start to increase, okay, then it will open the fresh air damper maybe for a while until your CO2 level drop to the healthy level, then you close back. So typically the set point is around 700 to 1000 ppm, okay, and it's also changed in the BMS.